This is in general a good way to solve Leetcode question. You have your function, right? You have the function that Leetcode gives you, and now you want at the end to return the answer, right? So you check breaking condition. Is it breaking the condition, the current status that I'm in? If yes, fix the breaking condition. So we can have multiple breaking conditions. For example, here we can have a breaking condition on the max and min that we track. You can have a breaking condition on the sliding window itself. And we check breaking condition, fix. Once we fixed all the breaking conditions, make sure we have the left and the right on the right place. And then we can update our answer, usually with some function max of the previous answer and the next one. So you see, this is a pattern. Fix breaking conditions, update the answer, at the end return the answer. Pattern. When with that, let's move directly to the answer. All right, so we continue with checking the answer for the longest subarray that is holding the condition of the limit. So you see we have the signature of the function, we have the area of the numbers and the limit, which is the condition. The goal is to find the longest window where max of the window minus min of the window is still not breaking the limit, right? Okay, so first we initialize the sliding window parameters. We have left pointer, the right pointer with the for loop. We have the left pointer, which will move if we broke the condition. Remember, we talked about broke condition, the left would move to the left, to the right, +1. And we initialize just the answer. Next, because we are going to track the minimal number in the window and the maximum number in the window, it's true that we can track it with the heap, but it's also possible and useful to track it with the queue. We'll see exactly. It's a pattern. Once you know this, you know how to track the max and the min with a monotonic increasing and decreasing. So we have two queues for the min and the max, and now we have here the pattern to scan the list with the right pointer. This is just the right side of the sliding window. Next, check breaking condition, check data structures, breaking condition. We have those two data structures that track the min queue and the max number in the sliding window and the min number in the sliding window. We check if they broke the condition. How can they break the condition? If they have any number inside, and the min queue -1, which means the number from the right side, the last one, is bigger than the number that we are currently in the right. If it's bigger than it, then it's impossible to track the current right number. So we must empty it. So with a while loop, and we also need to choose here whether to use an if and a while. We have chosen while, because as long as this min queue is breaking the condition, we pop items from it, and as slow as the monotonically decreasing, which tracks the max item on the left side, is breaking the condition, we pop items for it. Basically, okay, go dive deep into it. We are checking breaking conditions for the data structure that tracks the minimal number, and for the helper data structure that tracks the maximal number. Now, we are now applying the right item. Okay, we have the sliding window. The right number is moving to the right. And now that we checked that our data structure did not break the conditions, we can now append our current item from the sliding window to the data structure. And now we check yet another breaking condition. We are checking the actual condition of the question. See how we first check the breaking condition of our internal data structures. No one cares about it. The question doesn't care about them. We need to take care of our current data structures, right? So that when we go and check the actual question breaking condition, our data structures are okay. Here we are in a good state. Why are we in a good state? Because we checked the breaking conditions of our data structures, and we appended the current right number. We are in a great state. Now just check if we are not breaking the condition of the question. How can we break the condition of the question if the max number minus the minimal number is above the limit? If it's above the limit, then we cannot use this max number and min number anymore, so we remove them from our data structure. We increase the left because we broke the sliding window condition. And now, what is our state now? We checked the status of our data structures. We appended the right number. We checked and fixed, right? We fixed because we had here a while. So we fixed the status of our max and min value. They are now okay with the limit. If we're here, our data structures are okay with the limit, so we can update our answer. So our answer is, the usual max between the answer and the size of our data structure. And we return the answer. So this was how to check for a sliding window length, who is max, when we know that the max item minus the minimal item cannot be above a certain limit.